All right, so in this video, we're going to go over how we can find the area of a region bounded by this equation, the x-axis and the line x equals 3. And we're going to need to use the properties of logarithms, how we find the derivatives of logs and how we find integrals of logs. So first thing is, it's saying, it's going to be bounded by this equation, y equals x over x squared plus 1, the x-axis and the line x equals 3. I mean, you really don't actually need to know exactly what this looks like. But you can just kind of just use some logic because if you're saying the line x equals 3, and we're saying the x-axis, so here and here, and then this, we plug in 0 to that, we know it's going to be at 0, 0. And we know that this is always going to be a positive number because you have a number squared and top will always be positive whenever x is positive. So it's probably doing something like this. I'm not sure, but we know it's always going to be above the x-axis. So there's no worries about it like going under or going below the x-axis. So again, just keep that in mind whenever you're integrating, and maybe don't have the exact picture. Okay, so all you're really going to do then is set up your integral from 0 to 3. Remember, the left-hand point is the line x equals 0. The right is x equals 3. And we're going to have this will be our function. This will be our line for y. So then, x squared plus 1. And then we got x over x squared plus 1 dx. And so here we're going to need to use u substitution to integrate this. So what we're going to do is we're going to make u the x squared plus 1. And du will be 2x dx. And we got x dx. So we just want to divide this by 2. And then we'll get 1/2 du will be x dx. And so we can go ahead and then rewrite this so far as the integral of 1/2 times 1 over u. Because remember, you have the 1 over u. And the 1/2 would be on top. Or you can write the 1/2 here if you want. It looks weird, but just kind of emphasize the point that you have everything in there. 1/2 du is the x dx. But now we're not going to use 0 and 3 for the endpoints because these are endpoints in terms of x. We changed our variable of integration to u. So what we can do is either integrate this and then rewrite the expression in terms of x, and then find the area by going and plugging it in and using fundamental theorem of calculus. Or what I prefer to do is just change these right away into endpoints of u. Then you don't have to go back and then you don't have to go back and switch the variables again. So what I mean is we want to find what u is when x is 0 and when x is 3. So we got let's write that over here. So when x is 0 and when x is 3. So when x is 0, if u is x squared plus 0, then u will just be u will just be 0 squared plus 1, or just 1. We're just going to plug 0 in for there. So 0 squared plus 1 is just 1. And then x equals 3, u will be just 3 squared plus 1. Or u will just be 10. So now we rewrite our endpoints as 1 and 10 instead of 0 and 3. So we can put the endpoints here, 1 and 10. Let's factor out that 1/2. So we got 1/2 times the integral from 1 to 10 of 1 over u du And now we can go ahead and integrate this. We're going to have 1/2 times the natural log of the absolute value of u from 1 to 10. I guess you could take out that 1/2 if you want, and then multiply it all by 1/2 at the end, or you could keep it in there. Actually, let me take it out. So it will probably make the life a little easier. We'll keep that 1/2 on the outside, and then once we evaluate this, we'll multiply by 1/2. So this will be 1/2 times the natural log of the absolute value of 10. 10 is already a positive number, so we can just say the natural log of 10 minus the natural log of 1, because again, 1 is positive as well. Now we got 1/2. Natural log of 10. I don't expect you to know that off the top of your head, but you should know that the natural log of 1 is 0. Because e to the 0 power is 1. This will just be the natural log of 10 minus 0 times 1/2. And we can just evaluate that with our calculator. So 2.1/2 times about 2.3-ish. My answer will be 1.15. About 1.15, you can say. All right, and that's all there is to that.